Okay guys, night. So what we're gonna look on right now, we're gonna look at graphical method. We need a graph. That's important. This is an analysis and interpretation lab. Therefore, our aim is to find a cross-sectional area of an empty beaker and also find the mass using the graphical method. One important thing, video one looked on the procedure. We provided with a data sheet, and also we're going to look at plotting a graph of mass versus height of water. Mass of the beaker will be going on your y-axis, height of water will be going on your x-axis. After you calculate your gradient, your unit will be grams per centimeter. You'll be using the concept of density to calculate the cross-sectional area, in which I'll show you that calculation, and you're actually going to use a mathematical formula to find a cross-sectional area. You're going to use pi r squared times the height to find that there. What will happen that you're going to actually compare these two using the graphical method and the regular calculator method. You might ask why you didn't use the regular calculation method. We want to test your skills in manipulating formulas and doing graphs in physics. So that's one of the reasons. The y, you should determine the y-intercept, and the y-intercept is a point where the line touches the y-axis, and this has actually have a significance. It's the significance where there's no water in the beaker, but at the same time there will be a recording mass on the electronic balance. What would be the significance of this? We're expected to write some sources of errors. We could look at the classical one we call the parallax error while we're using our vernier caliper, or zero error while we're using the electronic balance. Okay, the conclusion is very important. We expect you to tell us from the graphical method the mass of the empty beaker from the graphical method, as well as the cross-sectional area, and this is the bulk we'll be getting these marks from. Anyway, enjoy your night.